Okay, we're marking the homework from yesterday, the lesson 6 thing. We have to simplify. All these questions say simplify, simplify, simplify. What is there to do? What do you identify first? I'm busy with exponents. And there is pluses and minuses, not that. Pluses and minuses. Therefore, I must factorize. Guys, if you start doing 2 to the x and adding this stuff and subtracting them, there's a line through your marking, through your work because you're on the wrong track. So, I have to factorize. And 9 out of 10 times, which type of factorization will it be? The common factor. And it's 2 to the x and 2 to the x. It wasn't written like this in your textbook. This is step 6, the second step, which is 2 to the x minus 1. Are you with me? Yes. Which then I split up so I can better see what's left when I take it out. And if you don't need this step, don't write it. You can immediately go to the factorization if you can see what's left. And the same thing here at the bottom, it was 2 to the x plus 1. I'm also going to factorize here at the bottom because there's also a plus in the middle. Sometimes one of them doesn't have to be factorized because there's no plus and minus. So for the top, I'll have 2 to the x, and then I'm going to have left 3 minus 2 to the power negative 1. Half. Thank you. It is 2 to minus 1, but you're going to write it as a half, so the quicker you do it, the better. And then we've got 2 to the x. 1 plus 2. Please remember, you have to, when you time it back out again, get there. So if you didn't have the 1, you didn't get this back. Are you with me? And then we have cancelling out, because remember, if you're factorizing, I'm going to ask you why you're factorizing. There has to be a purpose, and the purpose was to simplify, to cancel out, to be able to simplify. So what's left, it's got nothing to do with exponents anymore, it's just numbers. 3 minus a half, which is 2.5 over 3, and you can do that on a calculator. Yeah, I don't have to see that this is 2.5 or 5 over 2 or any which way you want to write it. I just want the answer. The sum is about the factorizing. Most probably 1, 2, 1, 2 for the factorizing. Answer? Answer? Half. Is a half. Alright, so there was a mistake. The question said 2 to the x plus 2, so that should have been a 2, then this would have been a 4, and by accident, purely by accident, this sum worked out to also still a half. For the next one, I need to factorize because of that plus. That's what identifies it and says, hey, stop, you've got to factorize. Am I going to factorize the bottom? No, it's already just one factor. Is it just one factor? No. It's one term, but there are more than one factors. If you want to, you can split them up even more. Okay, so at the bottom, I can just write it as 2 to the 2x and 2 to the negative 1. So I'm writing it as 2 factors. If I want to break this up more, I can say 2 to the x, 2 to the x. 2 to the x times 2 to the x is 2 to the 2x because I add the exponents, right? Depending on what I want to do, will I do it or won't I split it up? Then for this one, I still have to go and do what? Prime factors of 4 will give me 2 to the 2. Then actually you've got the 2 in a bracket and the x next to it, which in the next step I'm timing it to get to 2 to the 2x. So I'm seeing something happening here. There's my common factor. Alright? Plus. It's 2 to the 2x, and I didn't write it out separately in the first step, so now I'm doing it now. 2 to the 2x, 2 to the 1. Now I can see that there's a common factor, 2 to the 2x. Taking it out gives me 1 plus 2. And I'm so ecstatically happy that something's cancelling out, otherwise I was wasting my time factorizing. And then over. Are you with me, everybody? Yes. Because I know I'm going to simplify now. I'm not going to be busy with exponent laws anymore. So I've got these cancelling out. There's 1 plus 2 left. So 3 divided by a half. Quickly tell me with your own brain. 3 divided by a half. How many halves in 3? 6. How many halves in 3? Ah. Okay, next one. Still factorization because of the plus and the minus, agreed? Okay, so the bottom one, let me start there and say, can I factorize that? Is there a common factor, first of all? Is it the difference of squares? Well, there's a plus, so I don't even look further. Trinomial needs at least 3 terms. What else is there? Grouping needs at least 4 terms. Sum and difference of cubes. What times what times what? Well, I could actually do it, but okay, this is not what we're aiming for. But I taught you in the previous lesson, if you want to factorize, I want them to cancel out. So if I break this thing more down, it's going to be even less than 2 to the x, and this one is 2 to the 2x. So thinking logically, which one should be broken down to look the same as the other one? It's the top one. So if I break that one down, now start looking, what do you think it is? What do you think it is? The difference of squares. So difference of squares mean 2 brackets that look exactly the same, and the one is a plus and the one is a minus, but you've got a crib note. Since the bottom one's going nowhere, doing nothing, because sometimes you're going to have to factorize the top and the bottom, that's very extremely level 4, higher level. So if the bottom one's already broken down smaller than the top one, then I'm probably not going to break it down. So probably this is my crib note. There should be a 2x plus 1 at the top. Otherwise I'm wasting my time. Are you with me? Without thinking that, we're thinking that it should be 2x plus 1. But if we don't, and we just go for difference of squares, 1 is 1 times 1. And what times what gives you 2 to the power 2x? 2 to the x times 2 to the x. Are you convinced? Because when you time, you keep the basis the same, which is 2, and you add the x, and it gives you 2x. But you're actually cooking it right because you know that it should be cancelling out. And the answer is 2 to the x minus 1, which isn't just something like 6 or a half. It's fine if there are x's in the answers. Right. Okay, what does the question say? Simplify. What do you know you've got to go use? Exponents, but you can't use exponent laws because you must factorize. Are you with me? When you see a sum, you've got to know where it falls in the big scheme of things. So now I've got to factorize. But this top is how many terms? 3 of them. Is there a common factor? Because I hope that there is one. Because in general, 9 out of 10 times it will be a common factor. Now obviously it's a more difficult one, so it isn't. There's no common factor there. Okay. Something I saw that some of you did that I want to say on the video so that you can remember it. If you take out the 3 there, some of you said, then there's 1 to the 2x left. That is not right. You can't take out 3 from a power. The power consisting of a base and an exponent is a unit. You can't take a base away and take it out as a common factor. It doesn't make any sense. Why not? What is this answer?
2x.
What is this answer? 1. 1 to any exponent is 1. Even if it's a fraction, if it's a decimal, if it's a negative, I don't care. It's 1. So that means you're saying that 3 times 1 is 2 to the power 2x. Doesn't make sense. You cannot take it out. Are you with me? Mistake. You want to take out a common factor, but is there a common factor? No. So then what else? If it's not a common factor, we go through all the rest. Since there are 3 terms, I'm thinking trinomial. So to do the trinomial, we are going to have to do our little James Bond technique. Are you with me? All right. It's our little try thing. But can I do it? Are you able to see what the coefficients are? What is the coefficient here? It's 1. Because this is a variable, and this is why I want you to use the K method. So we are saying let K be equal to, but now this is the problem. What will I let K be equal to? 3 to the x, because this is actually... Can you just do that? Yes, I just did. Is that still 2x?
Yes.
Can you now see that I can substitute this with k? How can I just do that? You're allowed to do stuff in maths if it helps you. But whatever you do, I'm going to ask you why you're doing this. It's not wrong to write it this way, but why? Because I want to substitute k in the place of 3 to the power of x. So what is the sum going to become? K squared minus k and minus 6. Are you with me? So then at the bottom it should be,
K minus
so I have just made this sum immensely more easy. That's the purpose of the k method. And it's not just going to be by exponent, it's wherever you've got an expression or an equation and there are things that are repeating, and you can substitute it with a k to make it a more easy sum. It's no use just substituting x with k and making it 3 to the x2. You've done nothing. It's a much easier sum now. I'm not busy with exponents. I'm just normally busy with a quadratic trinomial, which you can factorize by saying 1 times 1 and 1 times 3 is again a nice easy one. What would be the factors? Keeping in mind your crib note. Why would you factorize if it doesn't? Cancel out. So I've got a good idea that one of them should be k minus 3. Are you seeing how I'm teaching you to crook? If you don't know how to factorize, it's a big problem though. But what should the other bracket then be? Because now I'm crooking it right. So I need a k so that it can give k squared. And I need a plus 2 to give me negative 6 and double check. The inners and the outers is minus 3x and plus 2x. Aha, it is. So fantastic, my crooking worked. This falls away and my answer is just k plus 2 and we move on. No, don't forget to make it 2 to the x plus 2. If you are able to factorize without k method, then wonderful. But then you need to know that this is still 1 times 3 to the 2x. This is 1 times, and this is 6. So if you're looking for your factors, looking with the 1 times and the 1 times and minus 6, do you see it's the same sum? It's just a little bit more difficult to see it and control it. Because then you're going to say, with your factors, say 1 times 1 and 2 times 3, right? 1 and 6. So you've got cross multiplication is 2, cross multiplication is 3. To get to negative 1, not 3, negative 1, you've got to have a minus plus, plus minus, and there are your two spy language, James Bond, all undercover. I can read that the two brackets are 1 plus 2. No, ma'am, it's not 1 plus 2, it's 1 what?
1k.
1 of this, 3 to the x. Because remember, if it was just x squared, you just said x times x. You still have to say what times what is x to the power 2x. So it's 3 to the x. And for this one then, would be, again, the 1 minus the 3. Do you see the spy language coming into play? So it's 1 plus 2 and 1 minus 3. But then it's still here again, I need x to the power, not x to the power, 3 to the power x. And you don't need the 1. But you can write it. So that means at the bottom, I didn't have to do anything. And I could actually let myself be led by that again. Knowing that it should look like that, it was actually easier. And then I'm finished. Done and dusted in 2 steps. And you're back here. So it's quicker, but you understand what you're doing. Can we agree that K method helps you?
Yes.
Definitely. All right. So you have a choice. Unless you all the time take the more difficult route, but all the time wrong, I'm going to say please do K method. But you don't have to do K method. Okay, so the next one, it's really Raina's trying to rack your brain a little bit. What's going on there? Again, simplify. It's exponents. What's going on with those exponents? Fractions. Okay, but does it stay the same principle, although it's a higher level of difficulty? Again, it's a trinomial, because we've done a few difference of squares, we've done quite a few common factors. We just need to do a little bit of trinomials and then we're done. And then you're going to feel, I need to go practice a little bit more and you write. Okay, so do them again and again until you understand. So if I want to do this sum, I'm going to have to decide, am I going to work at the top and the bottom and break it down? What are you looking at? If you break this down more, you're going to have something like half a fifth or whatever. I don't know what you want to do with it. But you see what I'm trying to say? Don't break this down, because you're going to break this down into x to the 1/5 and another x to the 1/5, because when you time them you get 2/5. And if it's 1/5, then please don't touch the bottom, because it's going to cancel out. And again, you have a crib note. Can I do K method? Yes, you can. If you want to break this up into 1/5 and say x to the 1/5 is equal to K, you can do K method, but it's not quite necessary for that. Alright, so this will definitely be a quadratic trinomial, but the bottom is just a two-term answer, so I'm thinking maybe this is my crib note. Thinking about the exponents, this one in descending power, 2/5, 1/5, 0, like you normally have with a normal quadratic trinomial. If this had been that, you wouldn't have any problem with it seeing that it is in descending order. It's still in descending order because it's 2/5, 1/5, and what's the exponent of x here? 0, because there is no x. So I could write x to the 0, which would still just make that 2. Are you with me? Just explaining to you that it's in descending order. Exponent 2, exponent 1, exponent 0 for the variables. Are you with me? So now I know that this thing can break down into x to the power 1/5 times 1/5, because when I time I add exponents and get back to 2/5. Will I break this one down? It doesn't even look possible anyway, but I won't do it anyway, because I'm breaking this one down to look like the bottom one. Don't touch the bottom one and make some more messes. Okay, so we're leaving the bottom crib note. And I'm thinking the top should look the same. Are you with me? Can I use K method? Yes. What would you make K then? X to the power of 1/5. Because there's one of them, and this would be then x to k to the power of 2. Are you with me? So it will work. But you don't have to do it. It's not that difficult. Breaking it down. So, if you wanted to go factorize, just like here, you're looking at those coefficients. So the 1 and the 2 must give you 1 times 1 and 1 times 2. Cross multiplication, and I'm getting 2 and 1. I'm doing too much here. Are you with me? You could have figured it out here with my crib note, and I want you to. So then, just to get back to the factorizing, I'm going to have to find plus 1, so it's plus minus, right? So it's x plus 1, no, not x plus 1, and x plus 2. So 1 minus 1, 1 plus 2. Have you got this method down from previous years? Then we just make it right, because this now should be 1x to the 5th, and you don't have to write the 1. And this will also be 1x to the 5th, and you don't have to write 1. And whenever you factorize, you can quickly check it out. See that it is negative 2. See that minus 1 and plus 2 does give me plus 1. And when you time, you add exponents to get to the 2/5. So are you with me? Any which way it works out. And we're cancelling out, which I'm happy about. Otherwise, I was wasting time for trying to factorize. And the answer is just x to the 5th plus 2, which you would have had if you did use K method as well. So when do we use K method? It's up to you. Sometimes it's almost impossible for the normal standard average kid to do a sum without K method, because that's quite difficult to do without the K method. But if you can get it right, once you have it, you have it. Okay, so there's my answer. Also, again, it looks a little bit funky, but that's the answer. Okay. The new rule, well, not the new rule, it was a rule that you were taught in grade, I think even in grade 9 for the first time you saw it, but in grade 10 you were taught if ever you have a power or a number inside of a root, you don't have to. From now on, if I ask you what is root 2 is root 2, that's an answer. but it can be written without the root. And the rule is to remove that root, you say exponent divided by the root size. So that would be your numerator, and that would be your denominator, and you can't decide which one goes where. It's definitely the exponent here is going to be the numerator, and the n would be the denominator. Can't be anything else. Let's look at practical. If this is the sum, you've got 3 of them to go and do. Help me. So this would be x to the power of 3 over 2. We never write 2 for a square root, but there's a 2. Just look hard. 3 over 2 times with x to the 2 over 3. Nothing else. You can't swap it around. Oh, maybe we can cancel these out. Don't get crazy. You've got to have rules for everything. This is multiplication, so the only thing you can do is add the exponents. Alright, and at the bottom we've got x to the 1 over 6, because there's still a little 1 there. Nothing there, so there's a 1. Nothing there, there's a 2. What do we do with this? Normal exponent laws. When we time and divide and the bases are the same, we keep the base and add and subtract the exponent. So we've got 3 over 2 plus 2 over 3 minus 1 over 6, which I don't want to see with LCM. I just want the answer. Please. Over 2 plus 2 over 3 minus 1 over 6 is 2. Can somebody confirm?
Yes.
And that's it. But you need it. This sum tested whether you know how to get out of root form or surd form into exponent form. And that's where you're going to get your marks for. Maybe even 3 of them because you did it 3 times. Then 1 mark for the rest of it because you have to know that you must add and subtract for the answer. So a 4 mark sum. Let's try number 2 and see if you're getting there. What would we do? Now, if possible, and there's some stuff that you can time and add and whatever, you do that. But in this one, you have to start first because surds come before multiplication, right? So I have to do the surd, and the surd I've just taught you how to go do this thing about the exponents over the denominator. So what about the 8? Will it now be 1 over 3?
No.
It's true, but what is cube root of 8?
2.
You've always known it, and it's not going to change. It is true that it's 8 to the power 1 over 3, but that's still the cube root of 8, which is 2. So you know your cube roots, know your square roots, the first few ones. All right, and then what about the x? Now it comes into play. It's x to the power of 2 over 3, y to the power of 6 over 3. Can't I just write 2, ma'am? Of course. I'm just showing you for an example. And then times with x to the 3rd. You see I'm not writing the multiplication there. It's okay. You can. You don't have to. But now to simplify, can I still simplify?
Yes.
There are bases that are the same. And I keep the base and I add the exponent. So I add what? 2 over 3 plus 1 over 3 is 1. And I don't have to write the 1. And then y to the power of? 6 over 3 is 2. Please simplify. Don't leave the answer as 6 over 3. And that's it. Sum done. So this would be worth like 2 marks, 3 marks. I'm testing whether you can use the surd law correctly. New law. Well, the latest law. Let's do the last one as an example. So what are we going to do with 16? Think about this before you just start. It is 16 to the x over 3, it is. But later on, then you're going to have to look at 16 to 32. What are we seeing? 16 to 32. Go to prime factors. So whether you do it earlier or whether you do it later, you're going to have to do it. If you first want to say, let's do the exponent law, later you're going to have to change the 16 into 2 to the power 4. So if you want to do it and say 2 to the 4, inside still the root, don't use the 3 like I just did. Or you first want to say x over 3 and then go and say 2 to the 4. You're still going to get to the right answer, which I'm going to get next. Are you with me? Ma'am, there's order of operations, but this, it doesn't matter which one you did first. Same thing with the 32. So now I can decide, let me do this one so long. X over 2. Don't forget, its square root is a 2. And the 32 we're going to change to 2 to the 5. You should know that. 2 to the 5x, and still inside of a 6th root. And if you can do that all together, guys, I'm not going to punish you, but I'm scared that if you do too much in one step, you're going to make mistakes. That's all. If you want to say the 5x immediately over 6, you're right. Okay. So then, I didn't leave enough space. So we've got 2 to the power of, let's apply the law, 4x over 3. And this x over 2, I'm just going to leave it for now. And then this will be 2 to the... Oh, it's horrible sums, fractions. But shame, fractions also have feelings. Okay, we can not despise fractions. So we are adding all the exponents and subtracting them. What are we doing? 4x over 3 minus x over 2 minus 5x over 6. And now, it makes it a little bit more difficult because you're adding like terms here by adding the coefficients. And what are the coefficients that you've got to add? 4 over 3, that's the coefficient there, not 4. 4 over 3 minus a half, 1 over 2, minus 5 over 6. Are you seeing it now? Coefficient of x. Couldn't I have written this as 4 over 3x? Yes. And there's a purpose to that if I did that. To better see that this is minus a half x and this is minus 5 over 6 x, then you can better see that it's 4 over 3 minus a half minus 5 over 6 something x. Give me an answer on the calculator there, please. Which gives me? How did I get that? Calculator. You don't have to go LCD here. That's not what this sum is about. Not by far. I'm checking if you can go from surd form into exponent form, whether you did the prime numbers, whether you timed it in. This is the last of it. But definitely a mark for it because you've got to know how to add 4 over 3 minus a half minus 5 over 6, and that's your answer. Right. Alright, so then you will carry on and you will do these few sums for me for homework. There you go.